Every single time you tap, click, or swipe on your phone, you're placing your trust in software. You just expect it to work, right? Well, behind that seamless experience, there's this hidden, crucial discipline that keeps our entire digital world from falling apart. Today, we're going to pull back that curtain and look at the 7 core principles of software testing. All right, let's dive in.
To really get why this is so important, let's just start with a question. Think about your banking app, or the GPS in your car, or even the software that runs a power grid. What's the actual cost when just one single tiny bug slips through the cracks?
The answer? Oh, it can be absolutely staggering. I mean, we're talking millions, sometimes even billions of dollars in losses. But it's not just about the money. Software failures can have huge, real-world consequences. The stakes are incredibly high, which is exactly what makes this field so critical.
So how do we stop these disasters from happening? Well, that brings us right to software testing. And let me tell you, it is so much more than just a developer clicking around trying to find glitches. It's a structured, disciplined process.
At its heart, this is the definition we're working with. It's the whole process of checking that a product does what it's supposed to do. But notice the key phrase here, aiming to uncover defects. The goal isn't to prove that there are no bugs, and that's a really, really important distinction. The main job is to try and make the software fail in a controlled way so it doesn't fail on you, the user, out in the wild.
And this breaks testing down into its 2 fundamental parts, verification and validation. On the left, you've got verification. That's asking, are we building the product right? Does the code actually work the way it was designed? Is it built to spec? But then on the right, you have validation. And that's the bigger, more important question. Are we building the right product? Does this thing actually solve a real problem for a real user? You can have a perfectly verified, totally bug-free product that is completely useless because nobody needed it in the first place. You have to have both.
Okay, so with that foundation in place, let's get to the main event, the 7 guiding principles. Think of these as the fundamental truths, the core wisdom of all effective testing.
Yep, there are 7 of them, and once you really get these, you'll have the mental framework to think just like a professional tester. It'll change how you look at the apps you use every day.
All right, principle number 1 is all about timing. Test early and test often. This slide shows you exactly why. If you find a mistake way back in the requirements phase, it's super cheap to fix. But if that exact same mistake isn't caught until after the product has been released to the public, look at that. The cost to fix it can be over 100 times higher. It's just incredible. This proves that testing isn't something you just tack on at the end. It has to be part of the process from day one.
Next up, we have defect clustering, which you might know as the Pareto principle, or the 80-20 rule. And this is so fascinating. It turns out that bugs, well, they aren't spread out evenly. Instead, about 80% of all the defects tend to cluster in just 20% of the software's modules. Now think about how powerful that is. It lets testers be super strategic and focus their biggest efforts on those few high-risk areas.
Okay, Principle 3 has, hands down, the best name. The pesticide paradox. And the idea is actually pretty simple, but so powerful. If you keep running the exact same tests on a piece of software over and over, release after release, eventually those tests just stop finding new bugs. The system basically becomes immune to them.
And this just nails the concept, doesn't it? It's just like insects becoming resistant to a pesticide. Your software gets hardened against your old tests, but all the while, new and different kinds of bugs can be thriving in the parts you aren't checking. So to beat this, your tests have to constantly evolve and change.
Now for the rest of the principles, and they're just as critical. First, testing shows the presence of defects. This means it can prove there are bugs, but it can never, ever prove a product is 100% bug-free. Next, exhaustive testing is impossible. You just can't test every single combination of things the user could do. It's not practical. Then we have the testing is context-dependent. You test a banking app with a huge focus on security way differently than you test a simple blog website. And finally, the absence of errors fallacy. This one's huge. A product can be technically perfect with 0 bugs, but if it doesn't actually meet the user's needs or it's a nightmare to use, it's still a failure.
So, we've got the principles, but what happens when people ignore them? Let's look at a few of the most common traps people fall into, because understanding what not to do is just as important as knowing the rules.
Here are 3 of the biggest mistakes you'll see out there. First, ignoring early testing. We saw that chart, we know that leads to massive costs down the road. Second, getting stuck in the trap of thinking you can test everything. That just leads to burnout and these inefficient, never-ending testing cycles. And third, using some generic, one-size-fits-all testing strategy that completely ignores context, and you end up with testing that's either way over the top or totally misses the real risks.
So, what does it look like when testing is done right? Well, it isn't about brute force. It's about being smart, it's about being strategic, and it's about being guided by those 7 principles we've been talking about.
A smart strategy, for instance, means knowing you have different tools in your toolbox. You've got manual testing, where a person is actually exploring the app, which is fantastic for finding usability issues and getting that human feedback. And then you have automation, where scripts run the same repetitive checks over and over at lightning speed. That's perfect for things like performance tests. An effective team uses a smart mix of both.
So how are you going to remember all of this? Well, here's a simple little tool for you, the mnemonic DEEP CAP. It stands for D, defects presence, E, exhaustive testing is impossible, E, early testing, and P, pesticide paradox. Then the CAP, context dependent, absence of errors fallacy, and P for the Pareto principle. DEEP CAP. It's just an easy way to keep all this core wisdom in your back pocket.
And that brings us to one last thought I want to leave you with. The next time you open up your favorite app, think about that absence of errors fallacy. Sure, it might be stable, it probably doesn't crash, but does it truly solve your problem? Is it easy to use? Is it actually useful? Because at the end of the day, that is the ultimate test of quality.